Power transistors. Power transistors having control turn off and turn on characteristics, but they need a continuous gate signal, and they are having unipolar voltage link capability as well as unidirectional current capability. So it is these characteristics is having advantages, but these characteristics poor. To overcome these two problems, they are operated along with the inverse parallel connected diodes in DC choppers and in inverters. Power transistors have the family of BJTs, MOSFET, SIT, IGBTs. So BJT is nothing but bipolar junction transistor, whereas MOSFET is nothing but metal oxide semiconductor field effect transistors. SITs are known as static induction transistors, and IGBTs are known as insulated gate bipolar transistors. These are having the advantage of switching speed. Switching speed is high in these operators. For BJTs, it is near about 1.7 to 9 microseconds. For MOSFETs, 0.6 to 0.9. For 6, it is 0.55 microseconds, and IGBT 2 to 3 microseconds. Whereas for SCRs or thyristors, the switching speed is near about 8 to 400 microseconds. The power transistors, it is having poor voltage current ratings in hundreds of voltage and current, whereas thyristor can operate in thousands of volts and currents. The power transistors like BJTs, MOSFETs, SITs, and IGBTs used for low and medium power applications. BJTs is formed by adding P or N type doped regions in PN junction diodes. So if N type is added, this will become NPN transistor. If P type region is added, then this will become PNP transistor. There we'll be having two junctions. You can see here we will be having one junction, here also one junction. Similarly, in this thyristor also we are having two junctions. So it's a three terminal, two junction. Three terminals are known as collector, emitter, and bias, and two junctions are collector, base. Junction is known as CBJ, base, emitter. Junction is known as BJ. NPN, N, P, N. So collector, emitter, base. Emitter, base, collector, the symbol for NPN. For PNP, E, N, P. So collector, emitter, base. The symbol for this is collector, emitter, base. Steady state characteristics. Since we have three terminals, that is collector, emitter, and base, there is possibility of three combinations, that is collector, emitter, emitter, base, and base collector configurations. Possible configurations: common emitter, common base, common collector, in which a common emitter configuration is used for switching operations. Let us see how it applies. NPN type transistor. So this is my P This is my EC. VCC, IC, RC, RB, BB, plus and minus B, BE, in between these two terminals, plus, minus, B, C, this plus, minus, BBC, in between these two. Now, this is common emitter configuration used for switching devices. If you observe, this is our input base and this is our output terminal. So input current is IB and input voltage is not the VB, it's VBE. These are the inputs and the output is IC, it's the current, as well as VCE. Let us try to draw the input characteristics. VBE, IB. These are the characteristics. VCE1, VCE2, where VCE2 is greater than VCE1. Output characteristics. This is VCE, IC. So different values of IB I am drawing. This IB naught, IB n. The reason below the IB naught is known as cutoff region. This region is known as active region. Saturation IB n is greater than IB n minus 1 is greater than I1 greater than I not remember. A BJT or a transistor for switching purpose. So we always try to use in saturation region. Operating regions. First one is cutoff. In this, a BJT or transistor is in off stage since IB is not enough to make it conduct. The base junction as well as the base emitter junction, both are in a reverse biased. Then second operating region is the active region, and this region we use for amplification purpose. IC is amplified by gain. VCE and IB decreases. BE junction is forward biased, whereas CBJ junction is reverse biased. And third region, that is saturation, used for the switching purpose. CBJ and BJ both are in forward biased condition. The bias current is high, so PC is low. Transfer characteristics. A transfer characteristics should be drawn between the input-output functions. Output voltage, VCC, the same line we can consider a VBA as the input. And this saturation region active, and this is cutoff.